In my free time, I do a thing called software carpentry with Matt Davis, who's been a software developer for a long time and is very, very knowledgeable. And we'll be teaching you some tools that are not explicitly relegated to the realm of Python, but we'll be using Python tools to teach them. So today the topics are version control, to help you keep track of your files and your file versions while you write code and other things, and testing to make sure that your code is right. So these things are pretty important, but not everyone has ever had a chance to get those tools under their belts, and I'm really looking forward to sharing these things with you. The first step is this installation here. You can go to this URL. You're going to want to make sure these things are available. But then I'm going to briefly explain what software carpentry is, and then we'll launch into the tutorial. But everyone should probably go to this URL anyway, because that's where we'll start from. So software carpentry is an organization. Oh, I should also introduce so we have some people over time. I'm going to have you typing basically this whole time, hopefully. I'll keep my own talking to a minimum, and you guys will be fairly interactive. So there will inevitably be little issues, you get an error that no one else is getting. Raise your hand immediately when that happens so that you don't get behind. And a couple of people will be helping you. Matt Terry in the back with the Hacker Within shirt there representing. Valentin is down here. We have Kelsey Jordahl in the blue shirt. Raise your hand, Kelsey. And of course, Matt Davis will be available when I'm teaching and vice versa. So raise your hand immediately when you get stuck or whatever if some command doesn't work, and we'll just run over and make sure it works. Okay. So software carpentry, back to the topic, is a group of people who have developed a community around teaching software development tools that help scientists actually do science with their computers rather than write buggy code and struggle a lot. And you can find that website at softwarecarpentry.org. And in addition to this lesson, you'll find lessons on all kinds of topics. They're open source lessons, and you can take them to your own institution and teach them to your own institution. You can invite software carpentry teachers like Matt and I, who have done this a number of times, to come to your institution and teach them. It's a volunteer organization, so we volunteer to do this. It's like a volunteer thing. And people are really passionate, and we found that teaching your peers these tools is really effective. Anyway, so I would encourage you guys to go to this website if you want to learn basically anything about building software. All right, but now that we've covered those basics, I have one announcement from the organizers. If you have lost anything over the course of the last day and a half or whatever that you've been here in this hotel, conference center place, it's at the registration desk. They have a number of items that people have misplaced. And if you're missing any electronics, for example, go find them at the registration desk. Okay, so announcements done. We're going to go straight into the tutorial. And the materials for this tutorial are going to be in Readmes on the GitHub repo, and you'll get there just by clicking on this link, GitHub repo, on that URL. So everyone needs to just click on this link and just go ahead and look up when you're done so I know that who's done it. And you're just going to want to click there. So the URL you were previously at is this one, and the URL you want to be at is here. So you'll see that there's this repository that has a bunch of files and stuff. You can see that there's one part of it that's Git and one part that's software engineering. And the first part of this lecture will be Git. So click on the Git folder. If anyone missed that, it should be here. And you're going to want to click on the Git folder. All right. And then we're going to start with local Git by clicking on local. Okay, and you should see this. So once you see these notes, and if you don't see these notes, quickly raise your hand if you don't see these notes on your computer. Yep, we got 1, 2. Okay. Sorry, do it again. Our people weren't looking. This guy. There we go. Great. They'll get you to the right URL. All right. So I have this friend, Lupine Wolf, and he'd been working really hard on this project over the course of a whole day. He'd been coding and coding and coding. He had a deadline the next morning, and he finally finished it right before dinner. He had some dinner and went to sleep. The full moon rose, and in the morning, he woke up with no memory at all of the night before, but sat down at his computer, and all his code had turned to complete nonsense because transformed as a werewolf in the middle of the night, he destroyed it, okay? We've all been there, right? Like at some point you have some great idea and you change all your code or you change a document and it's hard to get back. But Lupine had his code under version control, and so he looked at what had happened overnight, and it was clear that he had become a werewolf and destroyed his code, and he was able to execute just one command to revert his code to the state that it had been in the night before. And I really genuinely want everyone to take a moment just to instill in you the importance of this task and think about what would happen if you turned into a werewolf and tried to destroy all your code. Because some of us have our code under version control, some of us have some of our code under version control, some of us have never used version control, and all our code would be destroyed completely. And the issue here is that basically, to work really comfortably with code, you need to know that you can undo things. And you know, like my dissertation work, for example, very important that it not be destroyed. And a few months before I was going to be like finishing my dissertation, my laptop was stolen. Sounds like a really scary thing, right? But it was fine. I got a brand new laptop and downloaded all the Git repos, and it was fine. I didn't lose a single thing, not a script, nothing, because it was all under version control. And that's what I'm going to teach you to do today. So now everyone has some motivation. I'm going to tell you what version control is. It also has a lot of applications to reproducibility, but those are obvious. The disaster scenario should be motivating enough. So version control allows you to keep a backup of your files and keep a history of those changes and manage bringing changes in from different experiments in your code into one code automatedly so that you don't have to copy and paste changes from different documents, okay? There are lots of different ways people have version controlled things in the past. Some of these are centralized version control systems like SVN. Raise your hand if you've ever used SVN. Right, okay, so raise your hand if you've ever used CVS. Right, so a lot of people have some centralized version control background. How many have used Git here? Oh man, geez, why am I teaching this? Okay, so I'll go quickly then. Generally speaking, Git is a decentralized version control system. And what that means is that instead of having just one lockbox of master files to which people commit and remove, commit and pull information, everyone has kind of their own lockbox, and there are many lockboxes, and those boxes can be merged with each other if you think of the files as being in a lockbox that you can like retract from and insert into. And I'll explain that a little further later, but my first desire anytime I learn a new tool is to learn how to get help. So in the command line, you can usually type man and then the command that you want to use. So I'm going to type man git while you guys open up your terminals. Everyone open up a terminal. The man page for Git is actually kind of funny. Oh, I got a hand up. The man page for Git is funny, as are many man pages. It's called it describes itself as the stupid content tracker because it's actually very simplistic. And you can see that there are a number of options for the Git command line tool, right? And one of the first options is a -- help. So presumably that's better than the man page. So we'll try git -- help. So this is the first command we're learning in Git, is git -- help. So everyone should have a terminal open and type git ---- help. And then hit enter. So this shows you most of the commands that you're ever going to use with Git and what they do in a very succinct way. It's actually really useful for the first few months of using Git. We're going to go over quite a few of them, not all of them. I've actually not used all of them, and I've been using Git for a number of years. So anyway, so this is how to get help. And in the event that during this tutorial you forget how to do something, because there are going to be exercises where I don't give you all the answers, you can type git ---- help, and you will find out what to do next. So hopefully you have this tutorial open here, and you can see that all this is in the notes. But since some of you have just installed Git and just gotten Git usernames and everything for the first time, we're going to make sure that we git configure. So to configure your Git user space, you're going to want to type git config ---- global user.name, and then whatever your name is, okay, into the terminal. And so what this is doing is telling Git, when I commit, this is who I am. And you can associate my name every time a file changes with those file changes. Because Git's purpose is to keep track of a history. So part of that history is who's making changes. Hey.
What do you like to check what you're setting up?
So I don't know, my favorite way is what happens if you open up ~.gitconfig. So if you have a text editor, you're going to want to open up a file in your home directory called .gitconfig, and it will tell you those things.
The first line.
Oh, sure. That's all I can do. But I can't move the projector. All right, great. I'll keep my important stuff off the first line. So in vi git config, you'll see that stuff. But go ahead and set up your email address too. And if you have a favorite text editor, use that. If you don't have a favorite text editor, maybe consider using Nano or something.
People with Git Bash or people on Windows probably don't have Nano.
So then just don't put an editor, and we'll see what it dumps you into.
Yeah. Git Bash will be VI.
Yeah, and if you do get stuck in VI and you don't know how to get out, I'll help you. It's okay. If you get stuck in Emacs, I can't help you. Yeah, I'm just kidding.
I don't think we've ever discovered a good setting for this on Windows.
Yeah. Yeah. Think okay, so that's funny. Great. So has everyone configured everything? Does anyone still need some time for that? Okay. So the commands that you're using are these. At least execute the first two. The last two are optional. And this is just telling Git, the program on your computer, how to associate your name with the place of author when you're authoring changes in a file. Because at some point you'll collaborate with people, and you'll have a file that has lots and lots of collaborators, and you want to see who's responsible for what lines and what commits. Okay, great. All right. So the first step is to create a repository. So what Git basically does is to save the first version of a set of files that you create. It takes a snapshot. And then over time, every time you want a snapshot, which should be often because it's exactly as large as your undo button, okay, that difference in time. So what Git will do is it lists some number of files that it keeps track of. You will add files to that list. And every time you want a snapshot, you'll commit. So the first step is to create a directory in which to keep those files and to make sure that Git recognizes it as a Git directory. Okay? So what we're going to do is some good science. So in your terminal, type make dir. We're going to make a directory. We're going to call it good science, right? Because good science is under version control, right? Otherwise, it's just a bunch of code that you can't keep track of, okay? And then we want to cd into good science. So once we've changed directories into good science, there are no files there. You can even double check that there are no files at all there if you type ls-big A. But if you type git init, you will initialize this directory as a directory that holds stuff I want to keep track of. And we'll call this directory your local repository, okay? When you type git init, it says, I initialized an empty repository, and then it gives you a hint. It says, I created a .git folder in this directory. So that .git folder is pretty interesting, and your first exercise is to investigate that .git folder, okay? By cding into it and telling me what you see. So this is how Git keeps track of your files. So I'll give you guys 30 seconds to like investigate in here and tell me something I don't know about this. So you can open up, for example, the config file, and you can see the version is 0 because I've created no revisions. It's got a couple other qualities. Here in info, there's something called exclude. Let's see what exclude is. This allows you to say the following files are excluded by default from version control. So for example, if you have object files, you may want to exclude those from version control, and you can add those to this file list. Okay? All of this is kind of advanced once you're in the Git folder, but at least you guys know the inner workings. The only thing that Git has done, it's nothing mysterious. It's just created a hidden folder in your repository. Did anyone find anything interesting in this folder while they were exploring? So I found something called description. Oops. So you can actually edit this file to put a description into this repository. So that's kind of nice, right? So that if you like stumble across it in a few years, you remember what you were doing at the time. That's usually there are Git command hooks to almost all of these things. So you don't have to come in and edit these files. It's actually more straightforward for a lot of people to use command line tools, which you can find out from Git Help, to edit those things. Some of them you do have to. I think that I'm not sure you can ignore files, for example, and I don't know, maybe. Well, yeah, but you have to open the file and then add stuff to it. Right. So you can use the exclude file, or you can use the .gitignore file globally, or you can add this to the, you can add a .gitignore file to do the same thing as exclude. Anyway. Yeah. All right, great. So that's getting a little off track, but so what we've done is we've created this repository. You guys have browsed stuff, and now we need to figure out, if you go back to your good science directory, you see there's nothing really intense in there. But what we want to do is put some actual science in there and then keep track of it. All right. So the first thing that you should usually do in a repository for posterity is to create a Readme, right? So that people can follow along. .rst is just a type of markup. I'm just going to create a file called readme.rst by typing touch readme.rst, and it's in there, right? Is it being kept track of? Not yet, because I'm going to bring this like a rock star with me to this board here. Okay. So this is actually not being kept track of until, maybe I'll just do this. All right. So there are 4 different types of files in your folder. Okay. There's one that's untracked. Okay. There's a type that has been modified, and I'll go over what these mean. There's a type that's been staged, and there's a type that's been committed. Okay. So there are 4 types of file. I just misspelled committed, didn't I? Okay. Great. So right now we have one file that's untracked. Okay. The first thing that we want to do is make Git aware of it by typing git add. And that will make this untracked file a staged file. Once it's staged, and I'll go over all this, we'll use a command called git commit to commit those files. Once that untracked file gets added and committed, it's in the repository in the state that it's in. Okay, that's great. But then you may modify it after that first snapshot. So this is basically you setting up a picture. Every time you want an undo button, basically every time you want a recorded version of your repository, you need to git add in order to stage the camera shot. Okay? And then you git commit to click the shutter, right? So there's sort of two steps of taking this picture. Once you've got the actors, these files, in the scene, you have to remind them to set up their poses. So once this untracked file has been committed once, Git's aware of it, so it's no longer untracked, but if you ever modify it, it's not yet staged. So you'll use git add again over time, and I'll show you how all that works. But this picture can stay up so that you guys keep track of what that means. But keeping in mind that there are these sort of 4 states in which files can be will help you keep track of what is going on in Git. So this Readme file, what kind of file is it? It's untracked, so we need to git add Readme, right? So that's your second command that you've learned. You learn Git Help and Git Add. I'm going to very quickly teach you another command called Git Status, and it gives you some information. It says this is an initial commit. So this is the first, we're staging the first commit in this repository. And you can read these, and it's very helpful usually. Changes to be committed. There is a new file called Readme, okay? And in order to unstage it, you can use git remove, which we'll go over. But in order to commit it, so I've told you you can use this git status, and it says all these things. But the next type is saving a snapshot. So this is where we are in the notes. What we want to do to save this snapshot is use git commit. And this is a really important thing to do really often. Like I said before, this is the size of your undo button. If you want to lose an hour every time your computer dies, then you should commit once an hour, right? If you want to lose 3 days, you should commit once every 3 days, right? So think of it that way and commit often. And in fact, the best kind of commit is kind of commit that is atomic. We've got someone in the back. So if there's a particular change that you want to be able to just undo that change rather than undoing that change and changes that are unrelated, you want to make a commit on that change. So this is a very atomic change. We've just added one file. So I hit enter when I typed git commit, and it bumped me into a text editor. This is my favorite text editor, but you may have been bumped into a text editor you're not familiar with. If you can't get out of that text editor, raise your hand. But what we'll do in this text editor before we get out is type a message for posterity. We're tagging this picture, this snapshot, with a message about why we did this thing and what we did here. So what we did here is we added the first file. This is the first commit, right? And you can type anything you want, but may I recommend typing something useful. It sounds really crazy, but over time you're going to get really lazy with commit messages, and there are going to be a lot of commit messages that are typo or bug, right? And this is actually not very helpful because later I'll show you sometimes you want to use those commit messages. All right, so to get out of VI, if that's where you landed, you're going to type escape:WQ. If you're in Nano, this is what you're going to have the escape sequences in the bottom there. So if you're not familiar with your text editor, raise your hand. All right, great job. So we've now committed our first commit, and you can admire your work. This is the most satisfying part of committing something. We type git status, and it tells us that we're clean, that there's nothing on our working branch that we need to worry about, and that we can go to sleep. and turn into a werewolf and nothing will happen. Okay. Yeah. Uh-huh. So if you don't type anything into the commit message, then it will say that's not enough of an informative commit message, and it won't commit for you. So it actually gave me that error message with the other editor open. You want to try it?
I mean, it might not do it now because I saved it.
Oh yeah.
Yeah, so now it's going to do it, but
That's fascinating.
and print it at the same time.
All right, we'll see this happen again, no doubt, in a bit. So that'll be very interesting. So she had a problem where, I believe you. Strange beasts, these computers. Yeah, sure can. So right now, if your laptop was still in, your stuff is still gone. It's not on the internet yet. We're going to get there. But what we're talking about, yeah, right now is your local repository. Very soon we'll go over remote repositories and how to push and pull from those. And that's a lot safer and more useful. And there's a third step. In addition to committed, we'll have some pushed and pulled and whatnot. That's a great question. So his question, just to repeat it, was, these are local, right? These are not yet on the internet, and the answer is absolutely yes.
So this is an equivalent like an incremental backup if you want to go back up to something.
Right. And so let's demonstrate that. So one revision is great, but lots of revisions are better. So let's create a history in this file system. We've now learned that the workflow for this whole thing should be that we make changes, right? So we modify files until they're a modified file. We git add the files that we want to stage. We git commit those files, and then we add a commit message. So there's like a 4-step process. So I want you to go over those 4 steps in this exercise. Yeah.
What's the purpose of the stage as opposed to the
So over time, you're going to want to, so in SVN, you just commit stuff, right? You say like commit these files all at once, and you have this big long command line that's like commit this one and this one and this one and this one. If you don't want to commit 1 or 2 of them, you don't. But you have this like long list of other files. So what this allows you to do is like incrementally be like, okay, I've added enough to this file. I'm going to make sure that this is staged, and then you can keep working before committing and modify other files while this one is like in the stage. The benefits of this are like questionable because it's paradigmatic, right? Like it depends on how you work and how you think. A lot of people git add and then git commit immediately. But a lot of people git add over the course of their work and are like, oh, I touched this file, I'll git add it. You know, and then, you know, an hour later they like change some stuff in something else that's related, and they want them all to be in the same commit, but they stage them at different times. So.
It's helpful for composing meaningful commits when you've made several changes. So you might make a few changes in a few files that aren't really related to each other, but you just kind of came across them, and so you did those changes. But you actually want to put them in 2 commits because one set of they're not all related to each other, and when you make a commit, you usually want it to be kind of one meaningful set of changes. So being able to stage only some of your files and then commit them, but leave other ones for another commit is handy sometimes.
So commit, I mean, so like in subversion, commit is kind of atomic. Like you say, I want to commit this file, and you can't really do that, can you?
Yeah. So, and in fact, we can show this right now, right? We're about to edit a file and git add and git commit it immediately. And it's just a sort of 2-step process. Like you say git add and git commit. I'll show you that there is a command line flag so that you don't have to do it in 2 steps, which we'll do very soon.
Can you git add the same file? So you git add it, and then you have to make one more change?
Once, yeah, and in fact, once you've git added it, you can keep modifying it, and it's still staged. It's sort of like putting the actor on the stage there, and being like, okay, you're going to be in this shot, and just sitting him down, but then like, you know, coming back to the camera and being like, you know what, move your arm here or there, and they're still on the stage. You don't even have to git add again. they'll just remain added.
You do.
Once you modify them, no. If you git add,
Your subsequent changes aren't part of the commit unless you add it again.
no.
Find out.
Go ahead, but I'm pretty sure.
My question was, is it, when you commit, is it gonna always have, do you have to keep git adding every time you modify a file to get the latest changes, or?
I don't think so.
I'll find out.
Okay. Matt and I are, really? Oh, weird. Okay. Well, I'll show you guys how I actually work, which is why I don't know the answer to this question. But that's next. I want you guys to stage and commit some new changes. What you'll do is edit your README file and stage it for the snapshot using git add, then git commit it and add a meaningful commit message. This will allow us to have a history in this thing. I'll do that meanwhile. Hopefully you guys have these notes open, so it's okay for me to move over. Did it do this again? All right, very soon I'll show you a flag that you don't have to worry about that message problem. What happens when you type gitlog? All right. So how's everyone doing? Is everyone mostly done with this? Okay. So 4 steps is a lot of steps, right? Modifying and adding and committing and then writing a message in a separate step. So there are a lot of command line flags that are really helpful with making things not 4 steps. Often what you want to do is exactly what you brought up, is commit everything that's different in your repository than it used to be and add a message, and that's it, right? So if it is the case that you want to commit all the things that are different in your repository from the last commit, then you can use the -a flag, which automatically adds all of the files that you have previously put in the repository at all. So anything that is not untracked and it has changed will be part of the commit if you use the -a flag. You can also use a -m flag to never enter the text editor. So this is going to help her weird text editor problem. So this is how I interact with Git almost every single time I commit, because I try to work atomically too, because it's really hard for me to work on 2 things at once. So I'll make a bunch of changes. I'll be like, okay, this is like a single commit, and then I'll type git commit -am. So let's edit our README one more time so that we can have a history. So instead of just saying this is my repository, I'm going to say this is Katy's repository. I'm going to save that file. Okay, so it's different than it used to be. And you can tell because you type git status, and it says, oh, this is a modified file. Okay. If you had untracked files, the status would also point out that there are untracked files in this repository. Okay. This modified file then is not yet staged for commit. It says no changes added to commit. Use git add or git commit -a. So that's exactly what we're going to do. We're going to use git commit -a. We're also going to use the -m flag. So you can type -a and m at once, right? Git commit -am, and then leave a message. This is easier. Okay, and it tells me what I did. And in fact, it gives me statistics on what I changed, which is kind of nice. It says 1 file change, 1 insertion, 1 deletion, right? Because like only one line changed at all. And what I did was change a word. Yeah.
Okay. I'm using Emacs, which always gives you a backup file. So I have a backup file called readme.rst.
Tilde.
Right,
Yeah.
curly thing, dash one dash curly thing. And I looked in my exclude and it says it's excluding it, but every time I do a status, it says untracked file. Use git add to commit it. Well,
Yeah.
I'm told that I don't want to hear about this file. What do I have to do?
So
To get rid
what
of that message?
what that means is that when you type git commit -am, you know, like, well, that's not true. It's not going to track it unless you ever add it. If you don't ever want to see it, then you can put that file in your git ignore. So it should be, if you create a file called git ignore, you can add that. I thought exclude would do this, but if you create a file called .gitignore, and then you say something tilde, you know, ris tilde or whatever, then I think that'll do the trick. And then you won't really see it, and hopefully it'll stop doing that. You can also change your Emacs settings in your Emacs RC to make that file go to a temp directory somewhere else if you hate those, which I do. Huh? Yeah, gitignore is known to get, huh? Oh, you have to add it. Oh, you have to add gitignore.
Most projects put their gitignore
Right.
under Git control so that it's part of the package and so that everybody gets it.
Yeah. And so then it is in your gitignore. Yeah, so you do have to add the .gitignore file.
But that's normal.
Yeah.
So one thing too about the Emacs backup files, and like make sure you have it's like tilde.1 or something.
Mhm.
Like it's the expression right.
Mhm.
And with tilde.
That's yeah. You should also change your Emacs RC.
Or you could change your editor in the Git global to Emacs-AW, and then drop it into VC mode. It knows that you're in Git and it won't generate the backup file.
All right, let's move on. So in these changes, sometimes it's nice to know what has changed. And so if you make an edit to your repository, if you make an edit to your file, there's a command line tool that allows you to compare two files. It's called diff, right? But that doesn't help you because you don't have two files. What you want to know is what's modified about your file, and Git has a diff. So you can say git diff, and it'll show you all of the changes in the repository that are that have been made since the last commit. You can also see the changes in the repository that are currently staged, which, because I haven't added the README yet for this commit, are none. If you used git diff -cached, it will show you what changes will be committed if you just type git commit right now, which are none for me. But if I type git add README again, and I type git diff cache, then I see the changes. Is that clear? Okay, so I'll repeat it then. So if I make some change to the README, which, like, in this case, I've made this "it contains good science" line. That's a change in my repository. If I type git diff, it will print out that change. And the way that it renders this change is it says, oh, well, I'm going to use this syntax for the old one and this syntax for the new one. And the new one, the only difference is this plus line. Okay, and that's how it displays these diffs. If you haven't added the file yet to the repository, git diff --cached won't show those changes. Git diff --cache shows you what is different in the staged version. What's up? That's exactly right. So what he said is a very succinct way to put it. Git diff shows all changes in the modified files, and git diff cached shows all changes in the staged files. Okay.
There's actually an option as well,
Mhm.
staged, and recent versions of this was added.
Yeah. So it's even more clear what they're trying to say. I didn't know that. I'm too old. Okay. So there are a lot of great options for git diff, actually. I often use git diffstat because I often have just forgotten which files I've touched rather than what I have added to them. I don't really care as much about what I've added. Sometimes I just want to know which ones I've touched, and the way to see that is git diff -- stat, which will just, in this case, because I haven't changed anything because I already committed it, let me make a change. Change. I think. It will say, I have one file changed, one insertion. Okay. So by modifying files and making changes and then checking out those diffs, you can see there's some stuff. So if you just want to see the difference in a certain file, like if you have multiple files and you just want to see the differences in one, then there's this syntax with git diff head, where head is the most recent commit. Head, that big H-E-A-D, is this. The most recent snapshot. So head is like is the tip there. It's that most recent snapshot. Okay, so now you're Wolfman, it's the morning, and you realize something's gone wrong in your code. And to find out what happened, you can type git log. So everyone type git log. And this is where all the information is in the power. You can see that you're listed there as the author, and you can see all of your commit messages and how silly they have been. And there's some great flags for this command. One of them is one line. So again, not wanting to see lots of things, I often just want to see the log messages, right? I don't really need to see all those hashes. By the way, those big numbers that identify each commit, those are called hashes. They're like a 40-character hexadecimal number that's related to what the structure of the repository looks like, and it helps. These commits uniquely identify, these hashes uniquely identify each commit. And that's how we will refer to those commits. You can also see graphs using git log. So this one is really boring, but as we talk about branches, that red line on the side will start to get slightly more exciting. Okay. So what happens when you accidentally stage a file that's not ready to be staged? So for example, if you create a file, and I've created some mistake file, all right? And if I say git status, I have this untracked file until I accidentally git add it, and then I realize, oh God, that has my password in it, right? For example, before you commit it, you can still unstage it. You can say git reset, right? So I have some discussion of how this all works. But git reset file name will just unstage the file. So if you say git reset mistake, git reset will then just take it out of the stage, and it's now an untracked file again. Right? So that's great. So now you know how to undo that. But what if you go all the way to committing it before you realize what you've done, right? So if I do that again, I git add mistake, and then I git commit mistake. And then I realize my password is in the repository history. The best way is actually to well, we'll revert actual passwords, but we'll call mistakes just like something that wasn't ready. Let's pretend mistakes are just some code that's really ugly, that's not ready to commit. You can git reset and then type the commit hash to where you want to go back to. And for us, it'll be the most recent one, which is the default. And there are different modes. To return the contents of all of the files, including the all the way back to this commit that you previously made. So we can use git log -- one line to figure out what the last commit hash was. And I probably want to go back to added git ignore. I want to go back to the state in which I was there. Because if I went back to So to get back one revision, I can say git reset -- hard. So the options here are hard and soft and mixed, and you'll find an intuitive, you'll intuitively understand this eventually. But this one will reset everything. And you can say git status, and you can say gitlog, and you can see that only these files exist in the repository. And if I type ls, mistake is gone, right? It's no longer in the repository there. Now, it is in the repository history, but actually reverting stuff we'll go over later. Another way to, go ahead. Yeah. Yeah, you can still reset to this one, right? Can't you? Git checkout. So this is actually still in the repository. The information is still hidden in your Git files. So if you added your password, there's another command, which I'll show you. But git reset is good if you want to go back to a version that worked and then start working from there. The history of your mistaken travels is still in the repository, so you can get back to it. And in fact, in order to get there, it gives you some instructions if you type git checkout, which is our next command that we're learning. So good segue, thank you. Go ahead.
How did you find the hash for that one? When I do gitlog, I don't see the hash.
I scrolled up to the past one. Yeah. No, you can go into the reflog file in that .git directory, actually. We don't need to go there. Let's just pretend that you know a lot of things. Let's see. The best way to do it, is definitely to just go into the reflogs. In a repository that's online, you'll have a sort of more graphical interface to like interact with that, and we'll do that in the next very soon. Yeah, I should probably move. So to get out of that branch, git checkout master. Okay, so let's talk about what these checkout commands are that I was just issuing. Git checkout -- file name will discard the modifications. So if, for example, I open up my Readme file, oops, sorry. If I open up my Readme file and I make mistaken commit, mistaken content, I probably shouldn't commit this yet. So if I change my README and I add it, or even if I don't add it, if I just change my README and I say git status, you can see it's this modified file. Sometimes you want to undo those things. You're like, oh man, I tried a bunch of things and it didn't fix the bug, and I don't want to commit this. This is garbage, right? You actually just want it to disappear from the repository. You haven't committed it yet. The way to do that, to check out this snapshot from the head, you type git checkout -- and then the file name. And it returns you to the state in which it was before. And you can read the README, and those changes have disappeared, okay? Because you never committed it, and they are not in the ref log somewhere. Those changes have not been ever snapshotted. So did everyone get that? We just learned a command, yeah. So I made a change to the README file. I tried to fix a bug and it didn't work, for example. And then I realized that it didn't work, and I decided to go back to the snapshot before I started making modifications. To do that, you type git checkout -- and then the file name. And you can see that the git status goes back to the commit that was the head at the time that I made that commit, that previously commit. So, and then if you open up the README file, those changes have disappeared. Okay, so that's one way to undo things.
So if you check out one file at a time.
You can actually check out the whole revision. So let's use Git Help. So you can use Git Help and then type checkout for details on how to use the checkout function. And there are a whole bunch of different ways. And one way to use git checkout is to type git checkout, the second one, and then just give the commit, and then it will git checkout the whole commit. So what you're going to now do is try it. This is your exercise, and you're going to try to create 5 files in your directory. Each will have 1 line of content. You're going to commit those files to the repository, change 2 of them, undo the changes, and print out the last entry in your log. So this will show you how to change and unchange and unstage and stage.
So if I get a modification of file and track it, and I want to untrack it, do I use the diffstat or the checkout?
You want to use, if you made changes and
And I track the file, I use git add, but I want to untrack it, but not to do the modifications.
yeah,
So I use checkout or diffstat?
you want to use git remove. So we're going to go over this pretty quickly, and then we're going to talk very briefly about branches and then about remotes, because I'm getting kind of behind. So, yeah. No, you have to, yeah, you have to atomically add untracked files in your repository. You can use regular expressions. So you can say git add, dot star or whatever, if you want. And then, right, and so here, for example, if I say git add file star, I add all the 5 files or whatever that I just created, and I can say git status. And it's now, there's 5 new files. Sorry, I don't mean to take up all this screen real estate. Oops. Heh. So what you're going to need is gitlog and git checkout and a whole bunch of stuff. So this printing out the last entry in the log, I think you just have to like pipe it into head or something. But that's a trick that you don't have to do. I mean, we usually teach this along with a bunch of shell tools, so we try to use those. Can you just say gitlog one line -1? You're saying like -1? Oh, I didn't know that. Uh-huh.
Is git reset -- hard and git checkout with the same -x-1?
Yeah, and in fact, default git checkout is the head. So yeah. So his question was, is git hard the same as git checkout? And the answer is yes, in most cases. Git reset hard. So great. So this S is not supposed to be an S. It's supposed to be an A. Sorry about that. That can change. Okay, so someone asked earlier, I know you guys are like working on this exercise, but I'm going to move along. Someone asked earlier if you git add something and if you actually want to remove something from either, so if you git add file 4 and you say git status, oh, sorry. Oh, I have to make a message change. You can get reset to unstage, right? We showed that. If you commit it, no problem, changed 4. And that's very different than taking it completely out of the repository, which is git remove file 4. So this is how you take something out of the repository. Let me make this big. So if you git remove file 4, the git status shows you deleted something from the repository. Now, the previous shots with that actor in it remain as they were. They retain that actor. But if you no longer want to track a file, you can git remove it, and that actor is off stage. You know, it becomes an untracked file, or you delete it, or whatever. And in fact, what does happen is it will delete it locally on your machine. You know, but then you can retrieve it if you want to go back to those snapshots. So, git rm will remove the file. Git commit will make that official for this. And you can see that file 4 is no longer in my repository. So that's how you take a file out of the repository. But it is still in the previous snapshots. To actually undo something, which is not really it's not really something you usually want to do unless private information or proprietary information that like you legally don't want online or wherever is in your repository. Unless there's been a big mistake, you probably never want to use this command, so I'm not going to have us use it. But there exists a command to actually erase commits, and that's git revert. I've actually had to use this. My advisor committed a bunch of stuff that didn't make any sense and broke our master repository, so I had to revert his commit once. But don't let those advisors commit anything. He tried really hard, and so we fixed it and then recommitted it. But it was going to screw up our repository history, so I had to use it once. But I've literally, in years of using Git, I've only used it once. Great. So we're going to take a mental moment. You've absorbed a lot of commands. You've got git remove, git add, git commit, git reset, git checkout, git help. You know what staging is. You know how to snapshot a repository. You understand the command line flags. You're good to go. You can create a repository on your machine locally that keeps track of everything. And that's awesome. You now have all of the capabilities of SVN, basically. What I'm going to teach you next, though, is something that's kind of clever and closely related to the paradigm of Git, which is branches. And like SVN does have branches, but they're just really hard to use. So if you've ever used SVN, you may have run across branches, but Git really works closely with branches. And what branches are sort of parallel snapshots, right? you may be making linear progress towards your goal, and you would never want perhaps a second branch. But if you want to keep one path clean and try experiments on the side and then merge them back when you know that they work, you might want to have multiple commits on the way to that working mergeable version. So what the example that I'm going to give you basically is that there exists some code, right? This code base that we're working with these various files, and you want to do some experimental bug fixes, right? You will create a new branch, and leaving the current set of snapshots alone and not adding new snapshots to it, you'll create a new branch to develop your solution. And you want to create that, try a whole bunch of things, make many commits, and then when you feel comfortable that this is what you really want to add back to your master branch, that master branch and the experimental branch can join again. And I'm going to show you how to do that. What basically it should be in your head is the way that people work together, or the way that people work on things that are under development. So you may want something stable in your master branch, and you may want things that are experimental in your development branch. So a lot of code projects work this way, where there's a master branch that has the code releases, the development branch that all the developers work on, and all the developers that have their own experimental branches. All of these branches can be then merged automatically just by compiling the changes on top of each other. Okay, so I'm going to show you how that works, and hopefully it won't be too much of a paradigm shift. So here, if we type git branch, we see that there is one branch with an asterisk called master. What this means is there's only one branch, and it's called master, and we're on it, asterisk. If we type git branch experimental, we can create a branch called experimental. And we type git branch, and it says experimental and master with an asterisk, because we're still on the master branch. So you can see my command line actually indicates master. You guys have been seeing this. This is not like a parentheses for my identity, which you may have assumed earlier. Indeed, this is the branch that I am on in my Git repository. Okay? And if I change branches, which you do with another use of git checkout, so this is actually kind of a paradigmatic problem. Checkout has another purpose, and it is switching between branches. You can think of this as the same purpose if you really grok that branches just contain other revisions of the repository. I'm going to let that sink in. Branches just contain other revisions of the repository. So git checkout is just checking out another revision of the repository when you switch branches. Okay. Is there a question? Sorry. You guys got it. Okay.
If there were anything new on that experimental branch, that blew away things that were in the master, when you did that checkout, it would blow away copies.
No, you can switch back to the master branch.
So I mean, in the local working copy.
Yes. You'll move. Well, you can then just move back to the master branch. Yeah. And they'll still be there. Fine. Yeah, there's something called stash, which a lot of people from SVN use a lot. Okay. So you git checkout experimental to get there. And now you're in a world, and you see I've changed my command line, which unfortunately you just have to set up some stuff. My command line now says I'm in the experimental branch. And it has the same files as the master branch because I branched off of that commit, right? There was like commit, and then we got to this stage at which I decided to branch off, and we branch off, and we have a version just like the original master version. But if I make changes here, sorry, man, never live code. Get real butterfingers there. All right. I can type, this is the experimental branch. I can do dangerous things here. So I actually always develop in a branch that's outside of the master branch, just for cleanliness. But you can say git status, and you see that there's something different, and it informs you which branch you're on, right? So once you've done this, so yeah, oh, here's another flag just to be aware. Once you're tired of a branch, you can delete it with this -d flag. I've showed you how to use this branching out. And there's, once we've committed some stuff, you know, you'll see that in the git log, right? Sorry, let me use gitlog one line. So you see my, oops, I didn't commit it. Yeah, okay. So now my modified file in the experimental branch has been committed. And I can see that in the log. Right? It's the top one. And I can go back to the master branch, git checkout master, and it's not in that log. So just by seeing this, you should understand like what branches do. It allows you to go to some other place and make other commits. I can now make changes in master, but how do I keep up between the changes that are happening simultaneously in these branches? So there's a command called merge that allows the Git repository to automatically move file versions into each other. So this is like calling SVN git SVN checkout actually. So if you're in SVN, like you've got a lot of new words to redefine. But if you want that experimental branch to be part of master now, or if someone updates something in master and you want it to be part of your experimental branch so that you can keep up to date, you're going to use this command called merge. So you say git merge, and we're in the master. So git checkout to get to the master branch, and you can say git merge experimental. And what that will do is bring all changes from experimental into the master branch, right? Oops. Git merge. I misspelled experimental. So that's what that fatal error was. Not actually fatal. Great. And now I can say git log one line. And in my master branch, that experimental change exists. So this is a way of pancaking or not pancaking commits. Sometimes you want things to be in a line, and sometimes you don't mind if they're chronological. It's a little advanced, but to avoid it, there's a flag called --no-ff. Great. So that's awesome. And we've just learned how to use branches. And we're going to have one exercise about branches, and then I'm going to talk about remotes. So we're in Texas. Oh, go ahead.
Just a quick question. Can you merge the other way? Can you go to experimental and then merge from master in case someone's changed it?
Yep. And it works exactly the same way. So in fact, if we make some change, you can make changes simultaneously in the two branches. You can have 7 commits in master that aren't in experimental, and 10 commits in experimental that aren't in master. And the guy leading you, your schizophrenic brain that leads the experimental branch, can merge those master changes in so that your experimental branch is up to date, or master can merge the experimental changes in. You could both do it. And you'll be doing that a little bit in the course of the next little while.
That's actually probably a pretty good use case for like having the sort of stable like bug fixing branch,
Right.
and then your experimental branch. So when you fix a bug, you can sort of push it over to your whatever experimental branch is you may have.
Right.
Make sure that all that stuff.
So just to capture that on the mic, I'm going to repeat what you said so that's in the video. This is a good use case for bug fixes where if the master branch fixes a bug that the experimental branch doesn't have in it, you want to merge that in so that the experimental branch agrees. Someone had a question? No. No. Master is the default branch that Git creates because it has to have a branch. On GitHub, there will be a slight difference between these branches, but there is no difference in the notion of branch. Like, Git knows nothing about which branch is which. I'm sorry? Yes, the most recent commit.
No.
Well,
It will
And then you'll maybe run into conflicts, which we're about to see.
So if I remove one line and remove one file and not remove the other,
Sure.
it won't have that line.
Well, it'll merge them and there will be a conflict. If you change two lines in the same, if you change the same line in two different files in two different branches and then merge them, there will be what's called a conflict. And then only your human brain can deal with it because the computer doesn't know how to deal with it. So we'll talk about that right now in this exercise. So what we're going to do is create two branches. One is the US and one is Texas. Git checkout US. Sorry, Git branch US. I'm losing my mind. Git branch Texas. And I'm sorry, I'm going to go a little fast, but I want to keep up. So you want to, so the things that we know, so I'm going to git checkout the US, right? And there's a bunch of files in here, and that's fine. I'm going to add some files that I know about the US. I know the US has a president, so I'm going to touch president. That's a thing that the US has. And I'm going to say git add president, git add, well, I'm going to say git commit minus am, adds the president, adds Obama. Great. Oops, git add president, adds Obama. Okay. And then things that I know about Texas, if I git checkout Texas, Texas has a governor, right? So touch governor, right? Git add governor. Git commit minus. Great. So bluebonnets, also, that's something we know about Texas. Texas has a state flower. Great. So what this is going to demonstrate is that you can have two different people working on different projects entirely, and you can merge those branches together. Okay. So what maybe you want to do is merge both of these into the US branch. So in the way that we were just talking about, if you have different files in different branches or different checkouts, if I git checkout the US and I want to add Texas to the US, I say git merge Texas. And I say, all right, git branch merge Texas into the US. And I say ls, and it's got all of those things, right? Now those things are all in the US branch. But I realize, oh, I know something else about, oops. I know something else about the US. It has a national anthem. Oops, sorry, I'm losing my mind. Touch national anthem. And I'm going to say, you know, the national anthem is, oh, say, can you see? That's much, I mean, that's it, right? Yeah. But Texas also has a national anthem. So I'm going to create a file in the Texas branch as well, and that's Texas or Texas. So that's all well and good. And now in each of these branches, I have a new file with some edits in it that's called National Anthem. So Texans think that the national anthem is Texas or Texas. People in the US may think that it's So Say Can You See. And we're going to try to merge those branches, right? Predictably, there may be a conflict. I'm just going to demonstrate that. If we want to continue moving things into the US branch, we go into the US branch, git checkout US. We type git merge Texas. And it says, oh no, You've disagreed about the national anthem. There's a conflict. There's a merge conflict, and the merge failed. The way to deal with this, it tells you, right? It says fix the conflicts and then commit the results. So this is a beautiful thing about Git, actually, that SVN really struggles with, to give like explicit instructions when you like run into a problem. So if you open up the national anthem file, you'll see the following. On the head, which is the US most recent commit, you'll see, oh, say, can you see? And in the Texas branch, you'll see Texas or Texas, and they're separated by these equal signs. If you have a lot more other content in your file, that content will be around this content if they agree. And only the content in between these arrows needs to be fixed. So you want to set this file to say exactly what you think in your human brain is correct, right? And what's actually correct is Texas or Texas. So git commit -am. Fix the national anthem. Okay. All right, and now I say gitlog, and oops, sorry. Gitlog -1 line. And you see there's a whole bunch of stuff that we did. And like, there were no conflicts with Rick and Obama, but there's this conflict with the national anthem. We used our human brain to fix it because the computer doesn't know which one is right when there are two conflicting branches.
In a more complicated situation where you have to have the line
Copy and paste. So, well, the two files were in it, right? I wish I still had it in there. But you saw that the content of both files was right there, right? Between the arrows. So the content of one file is here, and then there's like some lines, and then the content of the second file is there. And like you would use your mind to decide what those files in between these two lines need to look like. And maybe it looks like some combination of the two. In most cases, it will look like some combination of the two. You know, some guy fixed a bug down the hall, and you fixed a similar bug in the same code, you know, but they're right next to each other or on the same line or whatever. Then you're gonna just have both bugs fixed in the final version. And we'll try that out, actually. We'll clone a repository from GitHub. We're gonna learn some remotes really, really, really fast. So there's a command called clone. We're not actually gonna go through this exercise, but so all of this data here is on the internets here at github.com. This is in Matt's repo. My repo has a fork of it. And you can use git clone and then type git at GitHub. We're going to clone another repository, just not this one. And then type your favorite Git repository. There are lots of projects on GitHub. So I would encourage you guys to like look at GitHub. There are lots of Python projects. You probably have already seen many projects in the last day that are hosted on GitHub. There are other Git repository hosting sites like SourceForge and stuff like this. Like you can host things on, I don't know if you can use Git on SourceForge, whatever. But the way that this works is you clone some repository using the git clone command, and then you give it the GitHub address of that repository. And you will see all these files download themselves onto your machine, okay? And then over time, you can pull updates from that repository by using the command git pull. I'm going to move into the remote branch, and we're going to go into this in more detail. I know this is really fast. I'm going to go over it again. Okay. So what you want to do is scroll all the way up to the top here, and click Git, and click on Remote. We're going to start a new set of notes just for the next 20 minutes. So github.com is this place where we're hosting this repository. Anyone not at this URL? Yeah. You scroll all the way up and click on this Git right here is probably the easiest way where my mouse is. And then once you're there, you can click on Remote. So we've been working just on your computer, and if your computer was destroyed, it would be a serious problem, right? But there are hosting sites that allow you to put your repository on the internet and push and pull those commits up to the repository. Yep.
I work for a company, they aren't going
So there are private repository hosting sites, and there are easy ways to create a server that serves Git just to you behind some firewall. Your sysadmin can definitely set up a Git server on some secure machine wherever you work. If you just tell them I need a Git repository. You too can do this, actually. You just use git admin commands. It's actually really, really, really simple if you have access to that server and you know how to give people access to that server who deserve it. Yeah. GitHub has private repositories if it's just an issue of privacy. Like I own some private repositories that I'm just too embarrassing to put out there in the world.
The company I work for has a private, you can get kind of organizational accounts on GitHub, and so the company I work for has a private organizational account on GitHub with all of our private stuff.
Yeah, unless if you're an academic, it's 2 or 3 private repositories are free. If you're a ruthless capitalist, if you're a woman, you can get some free private repositories because they're trying to encourage some diversity. But ruthless capitalists in general have to pay for things.
It's extremely cheap, though.
It is extremely cheap. I think the micro plan, which is like 5 or 6 repositories or something, is $7 a month.
Well, no, for individuals, for organizations, it's...
The micro plan is $7 a month, I think, for individuals. Yeah. Yeah, if you want any collaborators on your private repository, over like 2 collaborators, as Matt's saying, you have to pay $20 or something. But if it's just you and your privacy, $7 a month. So there are lots of different places to host these things. Google Code has one. I used to host things on Google Code. Bitbucket, Launchpad, SourceForge. Launchpad has free private repositories, right? So Launchpad. It's either Launchpad or Bitbucket. Anyone know? Bitbucket has free private repositories. Thank you. So capitalists interested in Bitbucket might find it good. GitHub has some good qualities though that Matt will take you through some of those. Hopefully everyone's set up a GitHub account. If you haven't, do so. You can set up a free one for now and add privacy later if you're bored. Now we're going to go over the git remote command, and we're going to talk about forks, which is different than branches. Okay, the first thing to know is that git remote is a command that allows you to become aware of someone's repository that isn't on your machine or is not in this particular file set. You actually can have a git remote that's just some other files on your own machine. But typically the way that people use this is, I have a repository that's the same, it comes from the same repository as Matt's repository, and we want to collaborate on it. But I want to know when Matt makes changes so that I can incorporate those development changes into my repository sometimes. Making Git aware of those remotes is done by this git remote command. I'm going to show you how to use it by first having you fork our GitHub repository. So this page that we're on right now is a README within our GitHub repository. I want you to scroll up to the top, and click on SciPy Git Testing there. So I'm going to go back to where we were. I'm going to have you click right here, boom, and you'll get to the home page of this repository, which is where all of the course notes are. And all the way over to the right on the top, there's a fork button. And I want to see this little number go up to like 55. So click on it. Right now it's just 2. One of them is me. If you're involved in any organizations, you're going to want to fork probably to your user space rather than those organizations. I'm obviously in too many organizations. But what you want to do is click on your username, and it'll take you. It'll have a little like book, maybe. So has everyone clicked the fork button? We've got 25 of you. Good job. Nicely done. Good friends. I can tell who you are soon. There's a graph. That's awesome. Okay, so 26. We're getting closer. So what you have now done is somewhere in your user space on GitHub, which you can find your user space just by clicking on your username. We'll look at how productive Matt is. He's pretty productive. He's got some private repositories, though, so I can't tell how productive. So this is your space, and to get to your repositories, you can click on repositories. And anyway, your space will be at github.com, your username, SciPy2013, Git testing, right? So that's a real repository hosted on the internet that it's exactly the same as the one Matt and I have on our computers. And what you're going to want to do is, so now that you've forked it, I'm going to show you how to make your fork download itself onto your computer and then make itself aware of my repository and Matt's. Okay. So you forked it. Now you want to clone it. And what you want to do is type in this, git clone, and then the URL. Okay. Yes?
Working, I'm getting a message about, did you run Git update server info?
Interesting. Anyone else getting that? Maybe he needs to run git update server info. This should do the trick, but right. So mine did fine. You should change the capital YOU to your username if that wasn't clear. Sorry, maybe I should have made that more clear. Yes? So did you fork the repository? Yeah, so there was a YOU right here after GitHub, and you want to change that to your username. So mine's Katy Huff. Just ignore this real-time part. I already have a repository on my machine, so I didn't want to overwrite it. You can give that repository a different name.
We include the SciPy2013.
Yeah, just ignore the real-time bit. I'm going to...
The other way to do it is just go to your web page.
And copy the URL. So here on your user space, you'll see right here, there will be an HTTPS clone URL. And you type git clone and then copy and paste that URL. They just changed the interface. I have the new one. If you don't have the new one, that URL is on the top of the page. Are you on your user space? Yeah. So you don't have write permission to Matt's user space. Yeah, did you git config? I think you needed to git config. Hey, Matt Terry, can you help this guy? Awesome. So how many of you saw something that I have like right here? Awesome, it's looking good. Y'all are doing great. So now you have all the notes on your computer. You can go back and play with this if you want. And instead of navigating through the internet, you can get to those readmes on your computer. So sometimes GitHub gets a little startled by high traffic. So if it didn't download, you might try again if it works. All right, you guys are doing a great job. So let's go back. I'm going to take you back to these notes here. And we've successfully forked the GitHub repository, right? But what we want to do is make sure that that fork, your local copy, should be able to pull updates from Matt and I's repository online. In case Matt and I, for example, fix that typo, that's an S instead of an A in my notes, you want to be able to update. So in order to do that, you're going to CD into the repository. Mine's called real-time. Yours will be called SciPy2013 Git testing. Sorry about that. I just don't want to overwrite my old repository. I should have just moved it. If you type git remote, I see that there's only one remote, and it's called origin. If you type git remote -v, you see the verbose version of that, and it shows me that git remote -v shows me the remotes that it is aware of. It is aware of the remote repository on GitHub under my username, because that's where I cloned it from. Okay? the default name for that remote is origin. Okay, you can change that if you want, but what we're just going to do is add to it. We're going to say git remote add, and I'm going to call it Jiffy Club, or upstream. Actually, let's just call it upstream. And we're going to type in approximately this URL, but we're going to have Jiffy Club in it because that's Matt's username. So go ahead and copy this URL. And you're going to make yourself aware. And now if you type git remote -v, you can see that Matt's repository is something that you can call upstream in your. We're using Matt's because, I don't know, that was the original one, so I forked his, and we, like, it all comes from a whole bizarre community of these software carpentry things. Actually, I don't think so. So it'll report it to you however you typed it in. You may. All right, then it's probably fine. We'll find out in a minute. Those two then you can pull from. So what this means is that if Matt makes any changes to his repository, we can pull those updates into our machine and add them to our repository. At the moment, your repository looks exactly like ours. And in order to incorporate those changes, but if we made some changes, in order to incorporate those changes, you would use a command. You would either use fetch and merge or a command called pull. Matt, do you want to make a change to your repository? Thanks. So Matt's going to update something. I don't really know what. But what fetch does while he's doing that is goes to the internet and determines and pulls down that repository into your local machine. But it doesn't bring it into your branch. It just makes your local Git repository aware of what that repository looks like so that you can reference it. So this allows you, if you're from an SVN world, this is actually really cool because what it does is it allows you a lot more freedom to work offline. You can commit and make changes locally. You can merge or not merge locally. And then when you get off the plane, you can push back up to GitHub. Whereas in SVN, if you don't have immediate access to the server, you can't commit, right? So this is nice because you can make all the commits and merges and stuff you want, just as long as you have updated versions of all the repositories you'll be working with. To get the updated versions onto your repository, you'll type git fetch and then upstream, which is the nickname for Matt's repository that we made. We call it upstream. This is a canonical way to call it. To merge it, if you decide you like his changes just fine, you can type git merge upstream /master. So that means merge Matt's master branch, whether or not he has other branches, into whatever branch I'm on. Okay. Matt's going to give me the heads up when he's made some changes, but it'll take just a second. You can do this in one fell swoop with pull instead if you have specified what branch. So if you don't feel the need to investigate what files have changed before merging them, and you just want to update whatever's up there, if you just trust Matt a lot, you can type git pull, and it will fetch the new stuff and merge it at the same time. Okay, so this is typically what you're going to use is pull because it's one step rather than two steps. But if you don't trust your collaborators, if you don't know what's changed or whatever, you might git fetch and merge. All right, so Matt's made a change here, and so I'm going to git fetch upstream. And what it has done is said, okay, so there have been some changes. He actually made quite a number of changes just now, I guess. And so I can investigate them, or I can just decide to merge them. Where, in the interest of time, I'm going to just git merge upstream master and see those changes change. Now, and you can use git diff, by the way, to investigate them. We've already gone over this, but you can say git diff and then upstream and stuff. He's made changes to the Readme So we can say, open up in your text editor what has changed, git local readme.md, and I'm not really sure what has changed, so I can say, I can say gitlog -1 line. I should have actually investigated it. So this is the commit that he made, I guess. Yeah, I know. So I'm going to say git diff. And he's made some changes to the story here. Or white space to the story.
All I actually changed in there was the removing the file backup.
Oh, okay.
My editor probably changed it.
So Matt probably uses a different editor than I do. What do you use, Emacs or something? Oh, I knew that. So this is the actual change that Matt made. I had removing a file, and I had removing S file, and he changed it to removing a file. And otherwise there was a lot of white space and stuff that changed. And so we've now added his changes to our master branch. But our master branch is now different than our fork online in our user space. Our master branch now looks like Matt's fork, right? And what we might want to do is put the changes that we have now made locally online. So now you can think of these files as having another stage, and that is like pushed. And between committed and pushed is just the barrier of the internet. Okay? So what we want to do is then git push origin, which is what our clones are, what our repositories are called, and master. And you will see those changes on your user space fork. You need your password for github.com. Oh, that's my username. Okay. So the first time, if you use that HTTPS protocol instead of git at GitHub, at least the first time it will ask you for your username and password when you push. If you're struggling with a password or something, let us know. It's probably like just typing it in properly, the username and stuff. All right, so now you understand how to push changes to GitHub and stuff. I was going to have this example where I change stuff and then you guys merge a conflict, but we're getting pretty close to break time. So how about we come back here at 10:05, and you guys, if you're bored, can try this exercise. I'll make the change that's necessary. And yeah, you guys are on a break until 10. Go free.